Hello students, let's start off with surds, or we call it radicals, and let's see the concept of this. So let's check this. So what we say is if x is a positive rational number, okay, if x is a positive rational number and there is another number n, so another variable in fact n, and that is a positive integer, okay, then x raised to 1 by n, or we can say nth root of x is irrational, then x raised to 1 by n is called a surd or a radical. Okay, so these are the two conditions which you should remember. X should be a positive rational number, n should be a positive integer. So x raised to 1 by n will be irrational and it's called a surd. Let's take an example. So let's take an example for this. So we have cube root of 6. The 6 is a positive rational number, 3 is a positive integer, and cube root of 6 is an irrational number. So this is a surd. Right? Now let's check one few more examples and let's see if we can identify if it's a surd or not a surd. So let's take examples. So let's take the first one as square root of 5, then fourth root of 8, square root of 4, fourth root of 625. Now we have to circle the ones which are surds. So root 5, so root 5 means here there should be 2, right? It's raised to half. So 5 is a positive rational number, 2 is a positive integer. This is irrational, so it's a surd. This one again, 8 is a positive rational number, 4 is a positive integer. This is irrational, so this is a surd. Square root of 4. 4 is a positive rational number. Again, this square root. So here there will be 2. So 2 is a positive integer, but this is not irrational. Square root of 4 is 2. So this is not a surd. Fourth root of 625. Now 625 is a positive rational number. 4 is an integer, positive integer. But we know fourth root of 625 because 625 can be written as 5 into 5 into 5 into 5. So that means this is not irrational, so it's not a surd. So not every square root or cube root or fourth root will be a surd. You have to identify the conditions and then identify whether it's a surd or not. Okay, now let's write down few important points for this. First one, every surd. Now, this is known as radical. Mostly in American books, you'll find surd being referred as radicals. In Indian books, you'll find it's as written as surd. So, every surd is an irrational number, but every irrational number is not a surd. This is one important point. Example. So, if you just take an example, we all know pi. So, pi is an irrational number, but it's not a surd, right? So pi is not a surd, it's a rational number but not a surd. Okay. Second point, so whenever we have something like this, like we have written nth root of x, and if we write this way, nth root of x, we call this as a surd of order n. Okay, this is what we need to remember. n nth root of x is known as surd of order n. Okay, so that means if you have square root of 7, so this is a surd of order 2. Okay, if you have fourth root of 7, this is a surd of order 4. Okay, let's take few examples based on this. So let's say the question is, state with reasons if the following is a surd. So let's take the first one, which is square root of 27. Now, square root of 27, if we just want to, you know, simplify, we can write this as 3 root 3. So now 3 root 3 is a rational number, 3 is a positive rational number, and 2 is a positive integer. So this is a surd, right? So whenever in doubt, you can factorize and you can check. Let's check the second sum. Um, let's say we have square root of 2 to 5 into square root of 4. Okay. So now square root of 2 to 5, we know this is 15 into 15. Square root of 4 is 2 into 2. So I can write this as 15 into 2, which is equal to 30, which is a rational number. Rational. So this is not a surd. So in the upcoming lectures, we'll check another important topic on surds, and that is rationalization. So till then, take care. Bye bye.